The Pythagorean Theorem. We are looking at 8.98 of Texas Standards, where we would use the Pythagorean Theorem to solve real-life problems. So before we get too deep into what we are going to do, let's just review just a taste. We will not go in and talk about something that happened 316 BC before us, before you and me, pretty much before anybody. But what we will do is give you a format into what this particular theorem is about. Pretty much used in geometry, but we can also use it in regular mathematics as well as algebra. So we use this when we talk about a right triangle. And in a right triangle, the sides that form a right angle are called legs. So what are we talking about? We have 1, 2, 3 different angles. So we have 3 angles. Should we say lines, segments? Let's use that. We have this line segment that's connecting to this vertex here. We have this line segment which is connecting to this vertex, and we have this line segment which is connecting to this vertex. So we say that if a right angle is formed, and of course we denote this right angle with this little square box, and that right angle measures 90 degrees. So just a little history, we know the inside of the actual measurements for a triangle is 180 degrees. So that's leaving a split here between, if that's 90, between whatever two figures, 30, 30 or whatever, that's going to give us another 90 to add to 180. But anyway, let's go ahead and just talk about the format. So we say this is a leg, we say that this is a leg. Now we also say that there is another side that is opposite this right angle that we just drew. It's adjacent or opposite, and we call this particular side the hypotenuse, and we say that it is the longest side. Okay, so what we want to make sure that when we look at these particular triangles that we see two things, actually 3 things. Well, 2 things. We know that we see a little square which tells us it's a right angle, and we should know across adjacent from our square we have the longest side, and we call that longest side the hypotenuse. Okay, just a quick overview, and if we see that, we say that we have a Pythagorean relationship. So how do we get this solved? What do we use it for? We say that in order to get the hypotenuse, we must take the square, or should we say square A plus B to get C, and then go ahead and take the square root. As we look at our little setup, we have one leg is 6, one leg is 8. We're squaring them both, and we have the given hypotenuse is 10, and we're squaring them both, and see, well, 6 squared plus 8 squared equals 10 squared, and of course 6 times 6, 36, 8 times 8, 64, 10 times 10 is 100. We add and we see that indeed it does. So from an algebraic standpoint, it's the exact same thing. One leg A, one leg B, across from the right angle or the 90 degree or the little square is our hypotenuse. So we can say A squared plus B squared is equal to C squared, and this is our formula that we will utilize. Okay, so what we want to do now is take this formula with us everywhere we go, and let's work 1, 2, 3, maybe 4 problems so we can see the different ways we can utilize this Pythagorean theorem. Not just to find C, but we can use it also to find either A or B. All right, so let's take a look at a problem. So we need to find the length of an hypotenuse of a right triangle with a 15-inch leg and a 20-inch leg. So what I always say to do is let's draw a picture. And I am in the drawing pictures mood. Okay. And make sure we put our right angle. Now, what the problem told us, it said that this particular right triangle have a leg of 15 and a leg of 20. So I'm going to use this for my shortest leg and say this is 15 and this is 20. And they asked us, well, what is this leg or the hypotenuse? We don't know. Well, let's go and use our little formula. A squared plus B squared is equal to C squared. We can call this A, we can call this B, and I'm saying we just could call it. Okay, so I see 15 squared plus 20 squared will give us C squared. Now we need to do some math. So we have 15 times 15, and that's going to be 25. Carry the 2. 5 times 1 is 5. Make that 7. 1 times 5 is 5, and 1 we add. That's 5, 2, and 2. So here we'll get 225 plus, and we have 20 times 20. That's going to give us 400, and that's going to give us C squared. Now we will simply add 400 plus 225 and 5 and 2 and 6. So here we will come up with 625 is equal to C squared. So in order for me to find C is being squared, I must take the square root. Doing the opposite of squaring it is the square root. We always do the opposite. So when we're getting a number, we're getting a number or a variable by itself. C squared, and here we're going to take 625. Now, the things that's really amazing here at this point is if you can recall that we passed out a list, and on that particular list that we passed out, the list gave us our triples. No, it did not. It gave us our perfect squares. So we should just take our little list, look on our list, and say, what is the square root of 625? So you take a minute and do that. I'll just make sure. Okay, I found 25. So now we can say, since the square root of 625 is 25, and C times C is equal to C squared, so we say, why we say that? Because C to the first times c to the first, and anytime you're multiplying variables and they have no exponent, literally the exponent is 1. So we're looking at c to the first times c to the first, which is, you add the exponents, c to the 1 plus 1, which is c squared. So since the opposite, or should I say the square root of c squared is c, then we see that what we're looking for as a hypotenuse of 25. So now we can rewrite our problem and say it's 20 squared plus 15 squared is equal to 25 squared, and that satisfies our Pythagorean theorem. Okay, now keep in mind, we can do this not only with perfect squares, but we can do this also when we approximate. So let's go ahead, close this video out, and then draw another one and take a look at when we are not just looking for the hypotenuse, but some length. All right, thank you.